So, welcome to all to the second lecture of the second year physics notes. And the first lecture we have discussed what is periodic function, what is an even function and odd function, and different properties of even and odd functions. In this section, we will observe what is orthogonal property and how orthogonal property has an impact on sine and cosine function. So, this part belongs to orthogonality of sine and cosine function. So this heading is how orthogonal property has an impact on sine and cosine function. So to understand the orthogonal property, let us first understand what we mean by orthogonal. Orthogonality comes from the word that is called orthogonal. And as you know, orthogonal means anything that is perpendicular to each other. That means the angle between any two vectors or any two quantity, if the quantity belongs to any direction and the angle between them is 90 degree, then those are called orthogonal vectors or those are called orthogonal functions. So we already know that. Let us consider a Cartesian coordinate. I first let you understand the simple behavior of Cartesian coordinate on orthogonal property, and then we can directly skip to what is the behavior of orthogonal property on sine and cosine function. So orthogonal means generally mutually perpendicular. Mutually perpendicular. So this is a Cartesian coordinate system. This is Cartesian three-dimensional coordinate system. So in this system, we already know that one is called the x direction, another called is y direction, and another called z direction. So three directions are mutually perpendicular to each other. And in x direction, we have taken the first year in the chapter orthogonal curvilinear coordinate. We have taken in x direction the unit vector to be I cap, or it is otherwise called as E1 cap. So E1 cap means the unit vector along positive x direction. Similarly, in y direction we have this is j cap, or otherwise called as E2 cap. Similarly, in z direction the unit vector is k cap, or it is otherwise called as E3 cap. So E1 cap, E2 cap and E3 cap are three unit vectors which are mutually perpendicular to each other. That means the angle between any two direction or any two unit vector is 90 degree. That means they are orthogonal coordinates. So this Cartesian coordinate is otherwise called as orthogonal coordinate system. This is called orthogonal coordinate system. So the basic thing is, how can you know that this system is orthogonal or not? Because we have drawn the diagram, and from the diagram we have just assumed that this angle is 90 degree, this x and z angle is 90 degree, and y and z angle is 90 degree. So each are mutually perpendicular. So mathematically, to understand this, we cannot draw the diagram or simply say the angle is 90 degree. So to understand this mathematically, we have taken some assumptions, and the assumptions based on the principle of orthogonal behaviors. So that means if you make a dot product or a vector product operation on any two vectors, let E1 cap and E2 cap, or E2 cap, E3 cap, or E1 cap and itself E1 cap, so the answer will be different. So basically, orthogonal means first one is we have taken, if take E1 cap dot E2 cap. So one is along x direction and there is along y direction. So angle will be 90 degree and cos 90 is itself 0. So the dot product is 0. That means I cap dot j cap equal to 0, or in other words we can say E1 cap dot E2 cap is 0. Similarly, any two different vectors E3 dot E1 cap is 0. So if the two indices 1, 2, 2, 3, 3, 1, if the two numbers are different, then the dot product vanishes or the dot product is 0. And again we can say if the two vectors are equal, that means E1 cap dot E1 cap. The answer will be how much? It is similar to I cap dot I cap. So the angle between them is 0 and the magnitude is 1. So magnitude of each unit vector is 1 and the angle between the two vectors is 0. So cos 0 is 1. So we can say that this is 1. Similarly, E2 cap dot E2 cap is also 1. So the simple observation is that to understand the orthogonal coordinate or to prove that a Cartesian coordinate is either orthogonal or not, these conditions should be satisfied. So these are not only the 4 conditions, there are so many conditions. Like I have not taken E3 dot E3 equal to 1, I have not taken E2 dot E3 equal to 0. So there will be different combinations of E1, E2, E3. So I have not written all because that will be a lengthy process. So in simple understanding, we can minimize these conditions. We can minimize these all conditions to a single value or a single expression, and that expression or that condition is called as the condition for orthogonality. So I can easily say, let us see, let ei cap is a unit vector for variable I. So I may be 1, maybe 2, maybe 3. Similarly, Ej is a unit vector in any direction. It may be, don't confuse that I is x cap or j is y cap. This is the arbitrary constant. This can be 1, 2, 3, anything. These i's are directions of unit vectors, and these i's are called the variables of the function e. That means I, j can vary. So I can easily say that this has two values. This can give value 1 and this can also give value 0. Likewise, this conditions. So but when it will give 0? It will give 0 when I is not equal to j. That means when the first indices is not equal to second indices. That means 3, 1, 1, 2, 2, 3. If I take the dot product, the answer will be 0. So if I and j are not equal, that means they are not similar. In that case, we will get the answer 0. And if i's are equal, that means whatever the value of I, that will take the value of j. That means if I equal to 1, j equal to 1. So E1 dot E1 for similar case. So for similar case, if I equal to j, then it will give us the value 1. Because if I is 1, j is also 1. If I is 2, j is also 2. So E2 dot E2 or E3 dot E3 for similar indices. For similar ij, we have got the value 1, and for different indices, we have got the value 0. So we have two values 0, 1, 0 and 1, or 1 and 0. Here, I and j can run from 1 to 3. So the variables ij or indices ij can vary from 1 to 3. So this is the condition for orthogonality. And we can again minimize it to another simple value or small value, that is called, this is called delta ij. You already know that what is delta function. Delta function is a function which gives the value 1 when I equal to j and which gives value 0 when I is not equal to j. So these whole value can be concentrated to a single term, that is called the delta function, or that is called the Dirac delta function. So delta ij means when I equal to j, it will give 1, and when I is not equal to j, it will give 0. This is already studied in our first year, the first semester. So there is no confusion about that. So these function or this condition, the whole condition is otherwise called as condition for orthogonality. So this condition is the minimum requirement or minimum condition for a coordinate system or a three-dimensional coordinate system to be orthogonal. So if this condition is satisfied, we can say each unit vectors are mutually perpendicular and the dot product of same unit vector, similar vector, is 1. So that is the condition for orthogonality of a coordinate system. So what is the, now the question is what is the relevance, what is the relation of these equations or these sections on orthogonality of sine and cosine function? Surely or directly we can relate to this orthogonality of sine and cosine function in the next section. But first, let us understand how we know that a system is orthogonal. So any function, these are unit vectors. So any function gives two values. Let's see. If any two functions on dot product or on any operation may be dot product, it may be cross product, it may be simple multiplication. As these are vectors, we have taken to be dot product because dot product is a suitable operation. So if these are functions, we can take another variable or another operation like integration, derivative, anything. So this operation EIEJ gives two values. Important. This one is important. What are the two values? One is non-zero value, and another is zero value. So we can say that one has non-zero value and other has zero value. So orthogonality simple means that on operation of two different functions, if that gives two values, one is 0 or one is vanishes or another exists, that means another is non-zero, then those two functions can also be called as orthogonal functions. Again I am telling you this because this is important for this section. If any two functions on a suitable operation gives two values, either 0 or another is non-zero, this may be 1, this may be 2, this may be 3. So this is non-zero value. One is 0 value and another is non-zero value. If you get two values, two different values, one is 0 and another non-zero, then we can say that the two functions are orthogonal to each other, or this condition is called orthogonality function. Similarly, if we replace EI to sin x and EJ to cos x, then and if that also satisfied an equation like this or equation in the form of delta function, then we can similarly say that sine and cosine has an orthogonality relation, and the relation is equivalent to that of the relation of the orthogonal curvilinear coordinate. So this section is important because this has a direct relevance with the orthogonality of sine and cosine. If you understand this section or this orthogonality condition on unit vectors, then you can easily understand the orthogonality of sine and cosine function. So again I am repeating that if the operation or if on suitable operation two different functions give one non-zero value and one zero value, or we can write them in the form of delta function, then the two functions are said as orthogonal functions, or the condition like this is also called as orthogonality condition. So we can easily understand this part. You can take a note of that, and in the next section we will see how sine function and cosine function has the similar kind of orthogonality condition, and that will be most helpful in the next coming section, which is called the Fourier series, or the dive into the chapter. So I am erasing this, and next I will make you understand what is orthogonality of sine and cosine function. This part is important. So let us see first. We have taken standard integral. So that integral is that this is the integral. So the operation is integration, because sine and cosine are not vectors; they are scalars. So scalars can never be made dot product with each other. So the suitable operation is integration. So integration of sine mx. So sine mx is one function and into sine nx. So sine nx is one function and sine nx is another function, and the variable is dx. So we can say that the operation is integration and the two functions are sine mx and sine nx, and the limit of the integration we have taken to be from minus pi to plus pi, because without a valid integration limit we cannot get an exact value of the integration. So to understand the exact value or to relate the integration to that of the orthogonality of coordinate system, we have to take some suitable integration. Otherwise, the value will be not defined, or the value will be not a function of a constant. So I have taken minus pi to plus pi because in this limit, these two functions are periodic. We have seen that a function, sine function, is periodic in the interval from 0 to pi, and this interval is also 0 to pi, because the interval is higher limit minus lower limit. So pi minus of minus pi is how much? So we can say that the interval is pi minus of minus pi. So this is pi plus pi, this is 2 pi. So the interval is 2 pi. As the interval is 2 pi, so the function must be periodic. So these two functions are periodic in the interval. So this integration you have to find its value. So, and this integration will give two values, because m and n are constants or numbers. So m and n can take any values. M can take 1, 2, 3 up to anything. N can take also similar values. So this integration will be divided into two categories, or the integration has two parts. That means we can take the same integration to be, let m may be equal to n. That means whatever the value of m, that is exactly same as that of the n, and m may not be equal to n. So these are the two conditions or two subsections of the integration. The same integration can be done in two ways, either m equal to n or n not equal to n. If m equals to n, then this function will behave differently, and if n is not equal to n, then this function will be same, because m and n are different and these two are different terms. So let us first check what is the value. Let us say integration is I. So whatever the value of I, these are two values. One is for m is equal to n, and this m is not equal to n. So let us first check what is the value of the integration if m is equal to n. So for what m equals to n, we have I equal to integration minus pi to plus pi. So if m equal to n, then the term will be equal to sine square nx dx. Because if m equal to n, so in the place of m we can replace n, or in the place of n we can replace n. Anything. This can be sine square mx, or if we put m equal to n, this can be also this is sine nx and this is sine nx. So we can say sine square nx. Anyone you can say. This may be sine square nx, or this may be sine square nx. So this integration can be done. You already know integration from minus pi to plus pi, and this can be split into the term of cosine term, because without a linear term the difference is impossible, or the difference is much difficult. So you have to split this function into a linear function. So you know that sine square nx is 1 minus cos 2 nx divided by 2 dx. This part you know that sine can be split into the form of cosine part, and this is called 1 minus cos 2 nx by 2. First integration. So again we will proceed further to check what is the value of the integration. Okay, so this integration will be, I am lacking space here, so I am doing it here. Okay, let's say I am doing it here. So this part will be equal to integration from minus pi to plus pi 1 by 2 into dx minus 1 by 2 cos 2nx integration minus pi to plus pi into dx. This part I will do further in the next section. I am doing the first integration here. So this I can split in two parts. 1 by 2 into dx, one integration, and the another integration is 1 by 2 cos 2nx dx. So the integration is split in two parts. So is equals to, this is 1 by 2 and dx has the integration of x from minus pi to plus pi minus half. This cos 2nx has the integration of sin 2nx by 2n from minus pi to plus pi. So these are the two sections of integration. So we have seen half. This x can take pi value or minus pi value. So the integration will be upper limit minus lower limit. So upper limit is how much? Pi minus. Lower limit is minus pi. This is minus pi minus half. Let us say closed look at this function. So if you put x equal to pi upper limit, then minus x is minus pi. So this is will be sine of an even pi. So even pi means sine 2 pi, 4 pi, 6 pi, or sine any pi. If n is odd, this can also be any odd pi. So we know that sine of any pi, like sine 0 is 0, sine 2 pi is 0, sine pi is 0. So sine of any function of pi is 0. So if you put pi here, sine 2n pi will be 0. If you put minus pi here, sine of minus theta equal to minus sin theta. So again we will get sine of 2n pi. So that is also 0 because any pi of sine function is 0. So it's simple get these to be 0 because sine of n pi equal to 0. We know that. So this section answers. So the answer will be, this is half, this is pi minus or minus pi. So half whole into, this is 2 pi. So we can say that 2 to cancel out and the answer is pi. So the first section integration has a value of pi. That means when n equal to n, the integration does not vanish. Or when n equal to n, the integration has a certain value, that is pi. Again, we will next see that what will be the value of the integration if you take n not equal to n. So you can take a note of that, and I will erase all the things, and I will again integrate for n not equal to n. So you note it down. And I am just writing the whole integration value. So simply we can write the integration to a single value which we have got pi. So I am erasing this integration and we can write it simply that this all integral value, this integral value will give us pi. So we integrate for n equals to n from the limit minus pi to plus pi. The value of the integration will be pi, where m and n are constants. I can also put a restriction that m and n is greater than 0. Like for example, for simplicity, m and n greater than 0. The two numbers m and n are always positive. That means greater than 0. So next we will see what will be the value of the integration when m is not equal to n. That means when the two sine functions are different, then we cannot merge them into a single function, which means they will simply be like this form, and we can integrate from minus pi to plus pi to get the exact value when n is not equal to n. So for this part, I equals to integration minus pi to plus pi cos mx, sorry sin, this is sin, sin mx sin nx into dx. So for this integration we cannot do it directly because it is simply the product of two different sine functions. So to integrate, first we have to make it to a simple addition term. Likewise, we have studied in your first classes. Let us say we have multiplied with minus half and 2. then half into 2 is 1, so the function or the integration is unchanged. So multiplying by half and again by 2 do not affect the value of the integration. So you can write that this is half from minus pi to cos pi, and this value we have already known that from first classes, 2 sin a into cos b, which is equal to cos a minus b minus cos a plus b. This integration you have studied in the first classes, because cos a minus b is cos a into cos b plus sin a into sin b, and cos a plus b is cos a into cos b minus sin a into sin b. So we will subtract, the cosine part will cancel away and we will get 2 times sin a into sin b, where a is mx and b is mx. So this part of the integration we have split it to 2 different terms. So this formula I can write here. You already know that 2 sin a into sin b is cos a plus b minus cos a minus b minus cos a plus b. So again, this is half. This value of integration is sin a minus n. I am taking x common from both mx and mx, divided by again a minus n, and minus this part of integration is sin of m plus n into x by m plus n, and the limit is from minus pi to plus pi. Simple, we have integrated 2 different terms, cosine term to sine term. Again, we will see what will be the value of the integration. We can know that. Let us see a and n are greater than 0, positive numbers. So the difference of m and n will also be a positive or negative number. That means a minus n is an integer. If m is greater than n, it is positive. If m is less than n, it is negative. So whatever the value of m minus n, it will be an integer or integral value. Similarly, if n plus n we take, m is positive, n is positive. So the addition is also positive. So the m plus n is a constant and m minus n is a constant. It may be positive or negative, but it is always positive. So if you put pi here, that means sine of m minus n pi. So sine of any pi, 1 pi, 2 pi, 3 pi, 4 pi, minus 1 pi, minus 2 pi. So sine of any pi, where n or the coefficient of pi is a constant, we will get 0. Simple. So sine of n pi is 0. Similarly, sine of this is a constant, this is also an integer, and this part of pi is also 0. You put plus pi or minus pi, that will not affect, because as sine is a odd function, the minus sign will come out and it will be behave as like pi. So sine of any pi is 0 and sine of this pi is 0. So whether you put plus pi or minus pi, so the whole integration value will be how much? 0. Because this is 0 and this is 0. So this whole integral value is how much? 0. Simple. This is the important point. That when m is not equal to n, the value of the integration is 0. Because sine of pi is 0. Sine of any pi is 0. So we have, I can write it simple, or I can just modify it. We have taken the integration, or we have done the integration. Then I can simply write that the value of the integration is 0. This part I have done. So now overall idea is when m is not equals to n, the value of the integration is non-zero, which is pi. And when m is not equal to n, then the value of the integration is 0, which is 0. So when n equals to n, it is non-zero, and when n is not equal to n, it is 0. It sounds similar like the condition of orthogonal coordinate system. So I can simply just write it here that this has 2 values. One is pi and one is 0. When we will get pi? When m is equal to n. So when m is equal to n, it has a value pi. When it is 0, when m is not equal to n, it is 0. So we can again say that this is pi, and when n equal to n, it has a value of 1, that is pi into 1 equal to 1, and when m is not equal to n, it is 0. So I can write it here m delta n, delta function. So when m is equal to n, delta m is 1. So pi into 1 is pi. And when m is not equal to n, delta function is 0. So 0 into pi is 0. So the whole idea is that we have to write the whole integration into a simple form. And the simple form is this one. The first integral form is this one. And this looks like to similar that of a orthogonal coordinate system, because in orthogonal system we have seen that ei into ej is 1 when n equal to 1. When n equal to n, it gives non-zero value. Remember, this is 1. When n is not equal to n, the orthogonal system has given value 0, which is ei into ej is 0. So we can easily compare this integration value, like its equivalent is like this. So ei into ej. We have not integrated because dot product is itself a mathematical operation, and here integration is a mathematical operation. So we don't have to integrate again here. This is the operation is dot product. Here the operation is integration. This is the only difference. So this has a value 1 and 0 when m equals to n, and when m not equals to n, it is 0. So we can write delta. Sorry, I have taken it ij. So I equal to j, I not equal to j. So delta ij. So this equation and this equation looks like the similar condition. When I is not equal to j, it is non-zero. Here also, when m is equal to n, it is non-zero. When I is not equal to j, it is 0. When m is not equal to n, it is 0. So this condition and this condition are more equivalent. So this is equivalent. This is equivalent. And the two functions or the two conditions can be written in the form of delta function. So we can also say that this is the orthogonality of coordinate system, and this condition is called the orthogonality of sine function. So we can say that this whole integration, this whole value, we can say that the whole value, I am erasing this just to understand or to compare. I have written this, but this is the basic thing we have started here. This condition is called orthogonality of sine function. This is most important. This condition is called the orthogonality condition of sine function because it satisfies the orthogonality property, which is one value has non-zero value and another is zero value. So this is the orthogonality condition. But the difference is there we get 1 and 0, here we get pi and 0. So there is no confusion. We have to just show that 1 is non-zero and there is 0. And non-zero will get when the two indices are equal, and 0 we will get when the two indices are not equal. And you can write it in the form of delta function. So this whole condition is equivalent to that of the coordinate system condition. So hence you can say that this is the orthogonality of sine function. In that case, we have seen that this is the orthogonality condition of a coordinate system because we have taken the variables to be the unit vectors in the each direction of the coordinate. Here, the variables are sine. So we can say that orthogonality of sine function. Similarly, we can prove, I am not proving it here, you can do it yourself, that integration minus pi to cos pi cos nx into cos nx dx when m and n greater than 0 gives value same case pi and 0 when m equal to n it gives pi, and when n is not equal to n it gives 0, and we can write it like pi delta m. So this is another condition. This is condition 2. This is condition 1. This is condition 2. So this condition is orthogonality condition for which function? Cosine function. So we can write that orthogonality of orthogonality condition of cosine function. So this part has the orthogonality condition of cosine function. So it has a similarity, it has a equivalence like the orthogonality of coordinate system. Hence, we can say this is also like an orthogonal condition. When we replace Ei and Ez by sine and cosine function and dot product by integration. So this is a simple idea. Dot product is replaced by integration operation and the functions Ei and Ez are replaced by either sine function or cosine function. If you take sine function, the value, the condition is called orthogonality of sine function, and if you take cosine function, it is called the orthogonality of cosine function. And these conditions are also equivalent to that of the coordinate system orthogonality condition. So hence it is called the orthogonal condition. Again, I will say just two property which will be used in the Fourier series. These are the orthogonal conditions, and another two property I will say here, like let us see. Write it down, then we will see. The third condition is the simple integration condition. The third integration is these two are orthogonal functions and these two are other integrations. The third integration is integration minus pi to cos pi cos mx into sin mx. This has nothing to do with orthogonal condition because this formula we have already known that. So you know sine cosine function is an even function and sine function is an odd function. So when we multiply an even function with an odd function, the whole value will be an odd function. So this function, this part, this is called a odd function because cosine is even and sine is odd. So product of even and odd is always an odd function. I have already told you in the conditions of or in the notes of the even and odd function. So the integration of an odd function from minus a to plus a or minus of any constant to plus of that constant minus pi to plus pi is how much? 0. So this condition is also important to understand Fourier series. So the fourth property is we can say integration minus pi to plus pi like sin mx into cos mx. Same case, sine is odd function, cosine is even function. So the product of odd and even is always odd. I have already told. So this is an odd function. So the integration of an odd function from minus pi to plus pi is always 0. Okay. So the four integrations, likewise, the first two are orthogonality of sine and cosine function, and these two are standard product of one of sine and another of cos, or one of cos and another of sine. So alternating the order, we have taken one to be cos and another to be sine. So if the order or if the two functions are different from similarity, that means one is cosine and one is sine. For different functions, the value of integration is 0. If you integrate from minus pi to plus pi, and if the two functions are equal, let this is sine and this is sine, and the integral value will follow like the orthogonality condition. If these two functions are same, it will be like the orthogonality condition of sine. If the two functions are cosine, it will be like the orthogonality condition of cosine. So any combination of sine and cos can be written in the form of these four integrations. 1, 2 I have already written, and this is 3, 4. So any combination, you take sine cos, cos sine, sine sine, or cos cos. So these all integrations from minus pi to cos pi follow in the four value of the integrations. Okay. So these four integrations are important. First two is called orthogonality, and second two are called the product of two different functions. So take a note of that and follow the order, follow the property, and try to understand what is orthogonality. In the next class, we will directly see what is Fourier series and how these integrations will simplify, or these integrations will help you to solve the Fourier series to a simpler manner. That means we don't have to do much in that Fourier series. These integrations will just do our work simple, and to understand the Fourier series, these integrations can be directly put into that equation. So thank you. you have noted it down and try to study it well. In the next class, we will see what is Fourier series. Okay, thank you.